College of Engineering here does research across a really broad spectrum. There are faculty that work on what you might consider traditional engineering research areas: fluids, materials, heat transfer, electronics. But these days, there probably is no such thing really as traditional engineering. Everything is transdisciplinary in many ways. We see so much of engineering applied to medicine. We see engineering applied to energy. We see engineering applied to transportation. These are all problems that challenge us as a society, and engineering really is pushing the envelope and figuring out how do we create new models, new materials, new products that are going to help solve the problems that we have as a society.
UMass Lowell tends to focus on manufacturing processes, and most of the equipment that you will see here has a lot of focus on scalability, and it's equipment that companies would use in the actual manufacturing environment. Nano-manufacturing is taking the nanoscience and technology developments and scaling them into commercial products. The HEROES project is a collaboration between the Natick Soldiers Center at Natick here in Massachusetts and our Nano-Manufacturing Center as one of the participants. And what we're trying to do is make new products for the soldier that are lighter in weight and have better performance. The unique opportunity of what we have here is that we have a lot of macro-scale plastics processing equipment in which we can integrate the nano-manufacturing processes that we have here. So the opportunity is to get different scales, nanoscale, microscale, macro scale, that are important for advanced manufacturing tools that I think the whole country will need.
The College of Engineering is one of the colleges here that works a lot with industry. And a lot of it is related to solving some of the challenges that the industry has. It also is creating some of the new technology that our industry can pick up on in order to make the next generation of products. We all know that it's a global competition these days, and for our companies to succeed, they have to stay ahead of the technology curve. And it's the faculty research here coupled with understanding industry challenges that is going to make that happen.
So UMass Lowell has a strong history of manufacturing research and expertise, and we're very excited about our strong partnerships with industry and the potential that it'll bring for us working with industry in these manufacturing institutes.
So our students here at UMass Lowell have unique capabilities in polymer processing and manufacturing technologies that are critical to industry. A lot of my students have graduated and gone on to work in advanced manufacturing, 3D printing, postdoctoral assignments at national labs, and also industries large and small.
Working with the Center for High Rate Nanomanufacturing gives our company the ability to access a lot of tools, and in particular a lot of world-class expertise in nanomaterials and manufacturing processes that we just wouldn't have the ability to do in-house.
3D printing is very exciting in that it offers the potential to create new prototypes, tooling, all different aspects. But one limitation is the lack of materials and new materials that can be used in the 3D printing process. Here at Lowell, we can compound and extrude into filament these new materials for companies to try.
3D printing is kind of the rage right now because you're able to make parts for a couple of dollars that literally 5 or 10 years ago might have cost hundreds or thousands of dollars to have produced. We have the capability to do not only design and processing using commercial 3D printing processes, but actually to make our own material as well. So here we have a couple different filaments, including ABS with algae-based filler. We have a thermoplastic elastomer. We have conductive polycarbonate and also polypropylene filament. So we're actually studying how we can make custom materials and how those materials need to be processed. And we're able to make fully functional assemblies in the order of kind of hours, days, no more than a week, certainly.
We look forward to these future prospects and potential interactions with industry as we go forward in flexible hybrid electronics, printed electronics, and 3D printing.